So welcome all. I hope my slides are visible. Whatever is written on the screen, all of you can see clearly. Thank you for joining today's live session on water and wastewater treatment. And I am Saptarshi Bose, a PMR research scholar from IIT Madras. So basically, we will go through few questions and we will try to discuss about few questions which are similar to your assignment questions and which might be similar to your final examination. So this will not only help you for your examination, it will not only prepare you for your examination, also it can help you to crack any government examination, any job examination, something similar kind of test. So basically, sometimes I need to admit new students, so it will be a disrupting session. Pardon me for that reason. So basically, we will start with uh, MCQ type question. What is the definition of term infant mortality rate? Mostly for this first session, we'll go through different kind of theoretical or conceptual question, very less numerical question, but the later on we will discuss various numerical questions as we progress through this course. So this is the what is the definition of term infant mortality. You can use your chat section or in call message section in Google Meet and you can type your answer like what is the correct answer A, B or C or D. You can type there. So I'll check who is participating really into this quiz kind of environment. I request everyone to at least try use the chat section to give the answer. Okay, I'm getting some answer. Okay. Bhavani said it will be A. What about others?
Sir, you are not audible.
I think now I am audible, right? There was some problem. Yeah, thank you. Thank you, Bhavani. Yes. Sai said, Pavan Sai said, it's B. What about others? Please at least try to participate. Okay, we'll go for the correct answer because we will not wait more. It will kill our time. So the B is the correct answer. The number of infant deaths for every 1,000 live births is very simple. Nothing to explain. Number of infant deaths for every 1,000 live births, not the total births, because total birth may include death birth. Right? So the live birth we will consider. So that is the main trick here. There's a difference between this general birth, it may include death birth also, and this is live birth. So that's the only difference. Right? So the next question is about the conversion from carbonate alkalinity as CaCO3 2 minus mg per liter to carbonate alkalinity as CaCO3. Actually, we are converting from carbonate alkalinity as CaCO3 to carbonate alkalinity as CO3 2 minus. So that's our conversion. Same for here, as a CaCO3 it's written mg per liter, and we are converting. We want to know what is the bicarbonate alkalinity as HCO3. Suppose you have carbonate alkalinity as CaCO3 or bicarbonate alkalinity as CaCO3 or hydroxide alkalinity as CaCO3, you have to calculate what is in terms of mg per liter, right? So that's the game here. This is kind of conceptual question or little bit numerical. Please try to calculate. Use your pen and paper and quickly answer. Which one will be the, or there might be the multiple correct answers, right? Yes, multiple correct options. I hope all of you know what is the molecular weight of each element. It's not given here. You can use your book, no problem. If you forgot was the molecular formula for calcium or carbon or oxygen, and get that, try to calculate as quickly as possible. I hope also you are aware of the equivalent weight, so you may need to use it here. So that's the hint for this question. Otherwise, it is very simple. Simple conversion only. 2 more minutes, then I will go for the answer. As at least keep one or two correct options. If not more, at least try to give one correct answer. Okay, so we'll go for the correct answer. So this will be the correct answer. Let's note it down. I will explain you why little bit. So this was asked as carbonate alkalinity as CaCO3 2 minus. Pardon for this write properly. Printing issue, typing issue. So it's written as zero point 0.6 multiplied by carbonate alkalinity as CaCO3, right? So we will try to know how this is coming as 0 0.6. Why it's 0 0.6? Suppose you know what is the carbonate alkalinity as CaCO3, then you want to convert it into mg per liter, right? Mg per liter as CO3 2 minus. So for doing this, what you have to write, that is the CO3. Sorry, I don't have this pen right now for today. So this is the CO3 2 minus and divided by your CaCO3. So you have to write this in terms of equivalent weight, right? So what will be the equivalent weight of CO3 2 minus? What is the molecular weight of carbon? That is 12. Suppose plus then 16 multiplied by 2, and you will get as 60. 60. And for CaCO3 it will be 100, right? The same as I have calculated here. Ca is calcium is 40, right? Then carbon is 12 and oxygen is 16 multiplied by 3. So you will get the molecular weight is 100, right? Now you have to calculate what is the equivalent weight. How you will do? You will divide this molecular weight by the charge, that is minus 2, right? Here. So you will divide this by 2. So it will be 30. And for CaCO3, how you will do? What is the charge of calcium? 2 plus, right? What is the charge of CO3? 2. That is 2 minus. So it will be 2. So this is the molecular weight divided by the charge, and I am getting as 50, right? So this is nothing but this point 0.6 is nothing but 30 divided by 50. So the equivalence weight of carbonate divided by the equivalence weight of calcium carbonate and multiplied by the carbonate alkalinity as COCO3. So what is happening actually? This is as CaCO3, right? What is the equivalence weight of calcium carbonate? This is the equivalence weight of CO3. 2 minus this equivalence weight are getting cancelled, and it is converted into the carbonate alkalinity as CaCO3 in mg per liter unit. So we will discuss similar kind of actual numerical questions. This is the formula based question or the conceptual questions. Then it will be clearer than this one. So we will do this later. So same as this bicarbonate alkalinity, how I am getting 1.22, just calculate by yourself. It is nothing but the equivalence weight of CaCO3 minus and bicarbonate HCO3 minus divided by calcium carbonate. So it will be, if I take the equivalence weight, it will be 61 divided by 50, right? Why 61? Because the charge is only 1. So 61 divided by 1, it will be 61 only, right? It's not divided by 2. Be careful. And same as hydroxide anion, it will be 17 divided by 50, and you will get as 0.34. So we'll move to the next question. Again, a theoretical question, very easy question. It's about the germ theory. You have to find out the correct statements, right, regarding the germ theory. So just a historical question. Please go through this question quickly and answer. Try to type your correct answer in the chat section. Who joined new, please try. Okay, yeah, Bhavani wrote A and B. Oh, sorry, thank you, I missed your answer. Okay, for this one you said right, A and B. Okay, fine. So others who joined later, please try to write your answer in the chat section or in call messages. Like you can write A or B or C option, something like that. Yeah, the correct answer is A and B. Thank you, Bhavani. So prior to discovery of germs, it was believed that the spread of disease was due to mesema or bad smell in the air emanating from rotting crops, sewage, or vegetation. Anignia Samuels hypothesized that cadaverous particles from mud on the hands of doctors made way to women's bodies during childbirth. So the next question is a useful question. It is very common for different kind of government job examination or gate examination. A combined sewage is the one that transport A, B, or C. Please type your answer in the chat section. Okay, I got one first answer from Bhavani. Bhavani is saying it's A. Let's see what others are saying. Please try to participate. There is no problem in participating, right? At least you can try. Okay, we'll move forward. So the correct answer is domestic sewage and stormwater. Right? It's A option, right? It's not with this industrial waste because generally industrial waste has different characteristics than domestic sewage. Maybe in case of domestic sewage, the BOD is very high, but in case of industrial waste, there will be much higher concentration of COD. So it is usually done with the stormwater. After the rain, whatever the stormwater is we are trying to collect, that can be merged with domestic sewage. It will have the similar kind of characteristics, so we can treat them together, but not with this industrial waste. So the next question is regarding water quality parameter, which can be measured within a short time, and that gives a general idea about the quality of surface water. We can quickly measure and tell whether this water is good or bad. This is a general understanding, not in depth quality measurement, but in a general way. So there are options like A, B, C, and D. You can quickly answer. Who are joining late, I request everyone to join on time because this is the last slot, right? We are running out of time. After some time, we will get some ring. We need to stop. Okay, I got one answer from. Okay, yeah, Jayashrima Reddy. It's saying it's B, then Bhavani V, Ganesh V. Right. Now some of you are participating, right? That's good. That's really good. So what about others? Others, please try. At least think. You can just check your notebook. Don't go for the internet. You can go to your notes your copy. You can check if you need any help. That thing you can do. But please don't go on the net or Google. If you have any confusion, you can refer to any book and try to give the answer. Write your answer in the chat section. I'm repeatedly saying this because new students are joining. Yes, the correct answer is B, as the dissolved oxygen, because in case of biochemical oxygen demand, you may need some time. If there is some mic open, please try to mute yourself. So in case of biochemical oxygen demand, you have to go through a longer process, maybe 5 days, 3 days, and you have to calculate. So it's a longer process. Same case of total organic solids, you have to take the sample out and you have to go to the lab. Then you have to analyze. In case of COD also, you need to decompose that material using some oxygen. It will take some time. So the quick thing is dissolved oxygen checking, and if this is very much below than the limit, usual limit, then you can definitely say that this water is not good. So the next question is again, it's a theoretical question or historical question regarding cholera. Basically, this is the first session, so we are having some historical question or theoretical question, but as the course progresses, we will get numerical or conceptual question. If you know, try to answer this one also regarding cholera. Yeah, week 2 assignment will be done in the next session, not this session. So because we will give some similar kind of question ahead. So week 2 question will be done in the next session. That's how it's designed by NPTEL team. So sorry for that. Oh, this is an easy one, so I'll not wait much. So the outbreak was more severe in the areas where populace drank water passed through the sand filters, and the discoveries by John Snow led the government to stop installation of municipal water filters, sand filter, and chlorination. So they were asking about the incorrect options, right? Not the correct options. So they will not definitely stop the sand filtration and the chlorination because the chlorination kills all the microorganism. It's oxidized basically the microorganism. So we use this for disinfectant. So we'll not stop the chlorination. So that's definitely the incorrect one. Right? So again, another question related to the cholera. What is the scientific name for this cholera pathogen? And whether it's virus, protozoa, or bacteria, you have to type. This is also a common question for various examinations. It's a simple question, but it usually appears. Okay, I got one answer from Sandeep. It's B. Right? He's saying it's B. Okay, Ganesh. Ganesh is saying D, and then Bala is saying it's B. Okay, let's see what's the other attack. If others are also typing. The correct answer will be right. With your already, it's bacteria, not virus or protozoa. Right? So please try to note it down. Then the clogging of sewers is due to A, B, C, or D. All of the above was filtering or the flow velocity is less than the scouring velocity, greasy and oily matters. What is the reason behind the clogging of sewer? We usually face this in our country, right? And different parts of our country. Mostly there are some overflows or the water stagnation after rain, different kind of issues usually face different cities of our country. Okay, I got answer from Sakshi, saying D, then Bala T, Ganesh T, and Sandeep T. What about others? This is a very easy question. If you don't know much, then also you can answer. Okay, Bhavani T, then anyone else? Okay, Radhika D, Priya D. Yes, the D is the correct answer. Absolutely right. So silt will come and sit at the bottom of your sewers. It will definitely stop the flow. Then the flow velocity, if the flow velocity is less than the scouring velocity, you know what is the scouring velocity, I hope. The minimum least velocity is required. Suppose these things are trying to deposit inside the at the bottom of the sewer, right? So the minimum water velocity you required to scour this, to take this away with your water. So that is the minimum velocity of the water you need to lift this up and take it with the flow. Suppose the flow rate or the flow velocity is less than this minimum scouring velocity, then what will happen? It will deposit, right? All the matters, maybe the suspended matters or whatever it is there inside the water, it will try to deposit. If the density is heavy or the density is more than the water, it is definitely deposit. And then greasy and oily matter, it will definitely attach to the surface and it will clog the overall area. So all of the above is the correct answer. Then high COD by BOD ratio of an organic pollutant represents what? A, B, C, or D. I hope all of you have a general idea about COD and BOD, at least some general idea. Then you can say if the ratio of COD by BOD is high, then what does it mean actually? It's a little bit tricky and conceptual question. So if your concepts are good, then you can answer. Okay, I got first answer from Sandeep. He's saying it will be A. Let's see what's other are saying. Uh, while answering, please think because don't answer blindly. Yeah, Radhika is saying it's a B, Ganesh D, Bhavani A, and Priya B. Please think carefully, then answer. Okay, Sakshi is saying A. Priya B. Fine. So I can see most of you are generally saying in between A and B. I got only one answer as D, right? So A and B are the common answers. Now please think between these two. Why most of you are saying A or B, and which one will be the correct one? A or B? Okay, Bhavan is saying A. Then Saidur Rahman is saying A. Okay. Then I can see that Saravanawala is saying as A. Why all of you switch to A? Okay, let's see. So think carefully what is the concept of COD and what is the concept of BOD. BOD is that kind of organic matter which can be degraded by microorganisms, might be bacteria, say bacteria. Like it can be used as food. Now, what is COD? COD will include BOD also. COD will include BOD as well as some kind of organic matter which cannot be degraded by bacteria, but which can be oxidized or degraded using chemical oxidant, say potassium permanganate. If you use potassium permanganate, you can oxidize this chemical or matters or this kind of organic matters, but it is not biodegradable. So this stands for your biochemical oxygen demand. This is the chemical oxygen demand. So this can be used as the food for microorganisms, bacteria. COD will include BOD. It will include BOD, and there will be something apart from BOD, which are not actually oxidizable by your bacteria or microorganisms, right? So if the concentration of COD is high in the ratio, it's a ratio, right? You know the basic concept of ratio. So high COD by BOD means COD is higher, this is higher, and this is lower. Then I will get this high ratio. Then what does it mean? Is it highly biodegradable? No, this is low biodegradable because CO2 is high in that component, in that uh, wastewater. The COD component is high and then the BOD component. So it is low biodegradable, right? Not high biodegradable. So the correct answer will be B. Please note it down carefully. Try to understand the concept of BOD and COD. If you cannot remember, please go through your notes. Please go through the book, go through the lectures. You will find. Okay, Bhavan is saying explain his wants. Yeah, I'll explain. Suppose let me erase all these things. It will be better for you. Yes. So COD is chemical oxygen demand, right? And this biochemical oxygen demand. So what is BOD? Suppose I have some wastewater. I collected some wastewater from sewer, suppose, or any wastewater treatment plant. So inside this, there will be some organic matter. This will, can be degraded by bacteria. So I hope you know, like I am telling everyone, including Navani, what is actually the BOD means, what is actually COD means, because I am not explaining here what is BOD and COD in details. Please refer to the lectures, it will be better for you to understand. Suppose I have some organic matter. Let me say something. It will be better for you to understand. Yeah, there is some organic matter. So how I will measure how much organic matter I have? What is the procedure to measure? I will try to degrade this organic matter, or basically I will try to oxidize this organic matter, and then I will find out how much oxygen is consumed, right? So I have certain, suppose I have organic matter of 100 mg per liter, but I cannot measure how much organic matter present in this water. I am just saying this hypothetically, that I have organic matter of 100 mg per liter, but we don't have any direct measurement procedure to actually analyze how much organic matter is present. So what I will do, I will use some oxygen, right? Or I will check how much oxygen was there initially, and then after the oxidation, how much oxygen is left. Then I will find how much oxygen is consumed, how much oxygen is actually consumed. Pardon for my pen today. There is some issue, technical issue with my pen. So how much oxygen is consumed from this wastewater? Then indirectly, I can say that much of oxygen is consumed. Suppose 100 mg per liter of oxygen is consumed. So I can say there was 100 mg per liter of organic matter. So I think it's clear for everyone. Now there are different procedures to find out. In case of BOD, what I will use some bacteria or some microorganism. I will put this microorganism inside this beaker, and after 5 days, I will check what is the oxygen right now, what is the oxygen present in this water, and before 5 days, there I can measure what was the oxygen, dissolved oxygen depth. So if we subtract, then we can say that much oxygen is consumed throughout the 5 days, and I can write down this is the 5-day BOD. This is a general concept. Please go through the lecture, it will be better for you to understand. So actually this BOD is consumed by the bacteria or the microorganisms, right? In case of COD, what I will do, I will add some kind of chemical, maybe potassium permanganate, right? And then I will determine how much dissolved oxygen is present here. What was the initial dissolved oxygen and what is the uh, dissolved oxygen after degradation or after oxidation. Just simple subtraction give me how much oxygen is getting consumed, right? And from that, I can say what is the COD. This is the basic general concept behind this. So now I will tell you different things. This was the basic concept, right? What is BOD and what is COD. So you can understand that inside this COD, there will be BOD, like whatever can be degraded by microorganisms, that can also be degraded by your chemicals. You can suppose I have a BOD of 100 mg per liter, and there are something extra 50 mg per liter of organic matter. Suppose I have total organic matter of 150. There is something 100 that is biodegradable, and there is 50 which is not biodegradable. Suppose the bacteria cannot use this organic matter as their food, so it will not be consumed by your microorganisms. So we cannot say it as your biochemical oxygen demand. This is, and I hope this is clear for everyone. This 50 will be extra, right? Now, how you will measure BOD? You will add some bacteria inside your water. After 5 days, what is your oxygen content? You can measure initial minus final, and you will get what is your BOD. Simple thing. This is a simple concept. And then you will take the same sample of water. You will add some oxidizing agent, suppose potassium permanganate. Then you will find out how much oxygen is present and how much potassium permanganate is consumed. Same thing, you can titrate in your lab. You can get how much potassium permanganate is consumed. From that, you can calculate what was this COD, right? And this potassium permanganate, suppose will oxidize this 100, it will oxidize this 100, and it will also oxidize this 50. So totally, it will oxidize 150, right? So this chemical, whatever I am using for COD measurement, it will not only oxidize this 50, it will also oxidize this 100 also, right? So basically, it will give a total scenario, how much organic matter was present there. So that's why COD will include BOD also. Now, if COD is high, then it represents that there are most of the organic matters are not biodegradable, because this ratio is actually COD by COD. That's the ratio, right? So if I have COD of suppose 200 and BOD as 10, right? So the ratio is 20 is to 1, something like that. And suppose I have COD of, suppose, what to say, 50, right? And this is 25 BOD. So what will happen here? 2 is to 1, right? So this is the higher ratio, 20 is to 1, and this is 2 is to 1. So what does it mean? It means that this COD, this sample, the first sample, is having low biodegradability, right? And this sample is having higher biodegradability, right? Because this is 2 by 1, 2 is to 1, it is 20 is to 1. That's the difference. So it has high biodegradability, it has low biodegradability. I hope this is clear for you. So the next question is again theoretical question. Pathogens in the water may cause what? A, B, C, or D?
All of the all of the
Uh,
above.
okay.
D.
Yeah, yeah. Right. This is a very easy question. What about others? The typing, I think. Yeah. D. Radhika D. Amol D. Ganesh. Yes. It's a very easy question, right? So all of the above. So the next one is the turbidity gives us an idea about what it is, all solids, BOD, then suspended matters and nitrates. Okay, I got one answer from Bhavani C. Yeah, Amol C. Priya C. Right. What about others?
C. Suspended matters.
Okay, okay. Yeah. You can also use your chat section to please answer. No problem. You can use your mic also. No issue. So anyone left? Okay, Ganesh C. Yeah. What about Sandeep? Now you are not answering. Bala and Sri Prabha, Vaishnavi. Please try to answer, think and answer. You can try to answer what are the easier questions. Like the last question, question number 10, it was very easy. So at least try to answer. Use your general understanding or general knowledge. Try to participate as much as possible because this is an interactive session, right? Yes, turbidity will give an idea about the suspended matter. Right. That's the C is the correct answer. So we'll go to the next question. Question number 12. If a small village uses groundwater for drinking purposes, it looks clear and smells fine, then the water is absolutely safe for drinking. Yeah, Abdul, yes, okay. Amol, yeah, Amol A, then Radhika B, yeah, B, Bhavani B. Who are joining late, please try to join early as possible because this is the last session and we are about to end. So no need to join. And okay, Saidur Rahman, false, Sakshi B, Sandeep B, false, right? Yes, the answer is correct. B, false. We cannot say if it is clear and smells fine. Yeah, it smells fine. There might be no ordinary gas as H2S. It's clear, might be free from iron, but there might be some dissolved ions. We cannot say about the dissolved ions. We also cannot say if there is some contamination. Suppose there is some nearby industry, as a pharmaceutical industry or phenolic industry. This phenolic water and mostly the pharmaceuticals doesn't have color. So some antibiotics is percolating through the groundwater and percolating into the groundwater through the soil strata. It can reach to the groundwater. We have many evidence that we can actually find this antibiotics. We can find some phenolic compounds which doesn't actually have any color present, vividly present in the groundwater. Actually, we are drinking that groundwater contaminated with various emerging contaminants. Might be bisphenol, or might be amoxicillin, might be tetracycline, metronidazole, and you need very sophisticated instrument to analyze. The general instrument, general lab will not be able to analyze this. You maybe require some HPLC or LCMS, then you can really find them. So the next one is the select the reasons why we choose coliform as the indicator of pathogens. Is present in the intestine of wombat, animals and humans, is harmful to humans, is present in great numbers so that it can be easily measured, low survival rate.
Answer is A. It is presence of in the intention of warm-blooded animals and humans.
There will be more than one correct options because it's written as select the reasons. Please try to find out another also. So it's there will be another correct option. Okay, you said A, Abdul, and then Priya is saying A, then Bhavani and C. Let's think carefully because there will be some more correct answers.
B also, it is harmful to humans.
Okay, yeah, we'll check. Thank you, Abdul. Thank you for your answer.
Yeah. So thank you, sir.
Okay, Sakshi is saying B. Okay, I think uh, most of you have answered who are actually answering throughout this session. Okay, so the correct answers will be A and C, right? Not B. It will be A and C because it is present in the intestine of warm blood animals and humans. We can quickly say that if any pathogens coming or they are actually what happens is humans or any other warm blooded animals, they can spread these infections like maybe cholera. Humans were also responsible due to the outbreak of this cholera. This is another other harmful diseases we saw. We recently experienced this COVID-19, and actually humans were spreading this. Right? So this is the indicator. And one more thing, it's not actually harmful for the humans. That's why we can safely take the samples in the lab and you can just analyze and you can count down and it's present in the greater number. So it is easy to measure. If it's a very small number, you need some high-end instrument to measure. If the number is very small, if the column is very small. And one more thing is there. Uh, Hello, if someone's mic is on, please try to switch off your mic. You can switch off your video also possible. So, and this coliform coliform will indicate if there is some harmful pathogens because wherever we can get this coliform, we can definitely say there are some harmful pathogens. We may not be able to directly identify them or we may not directly measure them, what are the harmful pathogens. But if we use this coliform as your indicator, they have some symbiotic relations. So if there is some coliform, there might be definitely there will be some harmful pathogens. So the next one is a again general conceptual question of wastewater treatment plant. So who have general understanding of typical wastewater treatment plant will be able to answer. It's a sequence, right? So which will come first and which will come second, something like that. It's basically regarding the sequence. Whether this primary sedimentation will come first, or then the grit removal, and then the biological treatment, or the biological treatment will come at the end. That's it. Was the correct sequence? Okay, I got answer from Amol. A, one A, yet
Grit removal and preliminary sedimentation, biological treatment, and secondary sedimentation. That is the sequence.
okay, correct. So I'll wait for few more answers. Yeah, Ganesh A and Sakshi A. Yes, the A is the correct answer. I think most of you have given the correct answer. Congratulations to all of you. This the grit removal will be first. First we will remove the grit. You know what is the grit, like the seeds or the eggshells, whatever the tea, coffee grout, the grit will be removed. Then it will go for the primary sedimentation. And after the primary sedimentation, we'll go for the biological treatment. Then the suspended organic matter will be degraded using the bacteria or the microorganisms. And whatever the dead cells are there, the bacterial dead cell, that will be removed in the secondary sedimentation. So that is the general sequence. So the next question is the correct statement regarding public water and wastewater systems. Multiple correct options are there. Okay, where we see, okay, ACD, right? Okay, fine.
It is A, C, and D.
Okay, thank you. And wait for a few minutes for others to answer. We were asking about the book. Yes, and go for the answer. So most of you are saying A, C, and D, right? So typically, domestic wastewater use includes water from flushing, bathing, and laundry. That's very correct. That's the general understanding of the domestic water. So it will come from flushing, bathing, and laundry, and kitchen also. And then the water demand for a city is not constant. It varies over the time, over different time periods of the day. So actually, it will vary. Maybe during the morning, around 8 to 10, it will be in the peak. Then it will go down. Then again at from 6 to 8, it will be again peak, and then at night it will go down. So this will be the general trend. So either this might be that night, at the morning, very early morning, then at the 8, around 8 to 10, we are getting this peak. And then from 6 to say 8 at the evening, we are getting peak, and then again down. So it will be a little bit higher than this night portion. Sorry, not into this, something like that. This will be your curve. So it is not constant throughout the day. And at the beginning of the wastewater treatment, yes, we need to equalize. There is one portion, it's called equalization tank, to equalize the flow to prevent the shock loading. Because if sometime the higher higher flow rate of water is coming, and then the flow rate is going to decrease, then again higher. So what will happen? It will shock the biological treatment system. So the bacteria, whatever is present there, it will not be able to accomplish with this high load of organic matter, and eventually there will be a lack of treatment. So whatever effluent you will get, it will be not properly treated, right? And actually the bacteria will not be able to cope up with this high amount of sudden shock of organic matter. So the next question, again, little bit numerical question. Yes, you are asking for some book. I'll try to tell at the end of Bhavani, end of this session. The concentration of MgSO4 in a solution is 240 gram per liter. So you have to convert the concentration in a different unit, moles per liter for M. It's a very easy question, maybe 9 or 8 standard chemistry question. If you know what is the molecular weight, and so molecular weight is given, right? The question of Mg or SO4. Try to calculate quickly. Yes, you need to know what's the concept behind the molar solution.
Answer is 2.
Yeah, thank you. Very good or quick answer. It's really good. We'll check the correct answer. What about others? Please try to calculate as soon as possible. It's very good. It was really very quick. Okay, Bhavani, two more, right? What about others? Then Radhika, two. Anyone else who has different opinion apart from two? Who is getting answer as 3, 4, or maybe 10, something like that? Amol, two. Okay, fine. I think now you are enjoying this live session. Most of you are very much active. One more minute, then we'll go. Anyone has different opinion, maybe 3.5, 4.3. Okay, let's go to the answer. So 2 is the correct one. So congratulations again, all of you. So for those who were trying but couldn't solve, I'm saying this, please try to note quickly that 1 mole, first you have to calculate what is the 1 mole of MgSO4, right? That is nothing but 24 plus 96. It was given. So 120 gram per mole. That is the molecular weight of MgSO4. So basically you are calculating what is the molecular weight of MgSO4, right? So now the molar concentration of MgSO4, it was given how much? The concentration of MgSO4 in the solution was 240 gram per liter. Now you have to convert it into moles, right? So, or the molar solution, what's the molar concentration? How you will convert this? Just for your reference, I am saying this. What is the molar solution? What is the concept of molar solution? What is the molar solution? Nothing. You take one beaker, you add 1 liter of water, simple concept. You take 1 liter of distilled water, you take how much amount of your component. Here it is MgSO4. So I'll take MgSO4. How much MgSO4 I'll take? What is the molecular weight of MgSO4? 120 gram is the molecular weight of MgSO4, right? So I will go for a balance. I will take the container of MgSO4. I will weight. Here you need to weight how much? 120 gram. 120 gram of your MgSO4. Take this 120 gram of MgSO4. Take this 120 gram of MgSO4. Add into this beaker. Mix it. You will get 1 molar of MgSO4 solution. That's it. That's the basic understanding of your molar concentration. So here, nothing else. It was given as 240 gram per liter of your concentration. Now you know what is the molar concentration, molar measurement of MgSO4. That is nothing but 120 gram per mole. That is the molecular weight, right? When we write not as only 120 gram, it's later written as 1 mole of MgSO4. That's what we have said. But suppose it was not written, then what we used to write? Suppose it's written as MgSO4 molecular weight. It is always written as 120 gram per moles, right? Per moles. So I hope all of you are aware of what is the Avogadro's number and all those things that behind concept. I'm not going into that much of depth. So that is the moles per 120 gram. And here, if you just cancel it out, and you will get, just cancel this 2 moles per liter, right? So it's as easy as that. 2 moles per liter, that is 2 moles per liter. I request someone open his mic. Please try to mute yourself. Then this question, again numerical question, 100 mg per liter of calcium is present in water sample. Convert the concentration to mg per liter as CaCO3. That's what I was trying to tell you in the second question, right? In the second question, I told you that there will be similar kind of question, a numerical question. You need to use the concept. There is also some unit conversion. Very easy. Molecular weight of calcium and calcium carbonate is also given. Just try to calculate the concentration of calcium in terms of mg per liter as CaCO3. Okay, I got first answer from Bhavani, 250 mg per liter. Okay, what about others? What about Abdul? You are performing very good.
Not worked out
Okay, okay,
properly.
no problem, no problem.
Okay, sir.
And yes, like Radhika, Amol, then Ganesh, Sakshi, Sandeep, you all were answering, right? And Matish, Priya. So all those who were answering Bala, then Saidur Rahman, Sandeep, please try to answer. You can refer your note, you can refer your book if you need any help from your book. Yes, we will go for the solution, Matish. We'll discuss the solution. Okay, Priya is saying 250. Good. Yeah, I got another answer from Sakshi 250 and then Sandeep 275. Okay, anyone has different opinion? Yes, Priya, I will go for the answer solution. Anyone else want to answer? Okay, fine. We'll go for the solution. So 250 mg per liter CaCO2 is the correct answer, but I will suggest Priya to change your method little bit. You have given the correct answer, no problem. And here it's correct because in case of calcium also, in case of calcium carbonate, we are getting 2 as the charge. So if you just don't divide it with 2, then also you can get the correct answer. You can write as whatever you have written, like 100 divided by 40 and then multiplied by 1000, and then you can get the correct answer. There will be no issue, no problem here. But in case, like if you just do this, apply this thing to different scenario, in case of hydroxide or in case of bicarbonate, right? So then there will be a issue. There will be some problem. So always try to use equivalent weight. Don't just go with your molecular weight, because if you just go with this molecular weight, in some cases you will get the correct answer. In some cases you may not get the correct answer. So there will be a big mistake. So what I am doing here, I already told you in the question number 2 how to do this. The similar concept behind this. First, you have to find out what is the equivalent weight of calcium. Molecular weight, that is 40 divided by 2, 2 is the charge. I'm getting 20 gram per equivalence, right? Then you need to find out what is the equivalent weight of CaCO3. How you will find out? 100 is the molecular weight divided by 2. Why 2? Because in CaCO3, if we dissolve this in the water, it will get in the form of Ca2 plus and CO3 2 minus. So the charge we are getting 2 plus and 2 minus, and this is also 2. So we are getting divided by 2. I'm getting 50 gram per equivalence. So it was given as 100 mg of Ca2 plus per liter, right? And we have to convert it calcium as CaCO3. How we will convert this? One equivalence, which is nothing but 20 gram per equivalence, is nothing but one equivalence divided by 20 gram of Ca2 plus, right? And we are multiplying with 50 gram of CaCO3 by one equivalence, this one, right? So we are converting everything into equivalence weight. So it will be better for us to equate those, because something is in a different unit and some other components in different unit, we cannot be able to equate them or make a single equation. So to put them into single equation, we need some equivalence of all of these different components, different two components, right? One is calcium ions and another is calcium carbonate. So what is happening here, this gram is equivalence, gram is getting cancelled, and we are getting in terms of mg per liter. Here we can cancel it out, whatever you can cancel, and 50, and from here to 50 mg per liter. So I hope this is clear for everyone. So that's it. Thank you for joining today's session. Hope all of you enjoyed today's session. And who joined late, I request them repeatedly that please join early at the beginning of the session because this is the end session for the day. This is the slot for 7 to 9. So you will also run out of time. I will also run out of time if you don't join on time. You may in a hurry to have your dinner, right? So or other entertainment. So it will be difficult for you to continue beyond 9 if you join late. Yes, thank you, Sarala. Yeah, Bhavani, I will suggest few book, but I'll suggest in a general way, not specific to your. Let me just type. It will be better if I type. Yeah, thank you, Sakshi. Thank you, everyone. I will type the name or the author name. Better to say author name. And this is the general water or wastewater treatment engineering books, not particular for any assignment. And if you go through these books, it will be useful for you. So first one is wastewater engineering. Please try to note it down. I am not writing the full name. Wastewater engineering, treatment and reuses by Metcalf. I'm just writing the author name. You can find out through internet. One is Metcalf AD. Then another one is water and wastewater engineering, design principles and practice. This is from Mackenzie L. Davis. This is from Mackenzie L. Davis, water and wastewater engineering. And then another book, environmental engineering. This is not water and wastewater engineering. It's a very small thin book comprising all different concepts of environmental engineering, including water and wastewater treatment process. It's a very useful book and very thin book. So the name is environmental engineering and the author name is Devi Roy. So these are three books, and you will also find out some suggested books on the NPL portal. Just go to the NPL portal where you will find the assignments at the bottom. I hope if there is some tab, you just click that tab and you will find some supplementary books or notes. I hope it's there. I'm not sure whether it's there for this session or not, but yes, I will share this presentation and not directly. NPTEL team will give you some link, and if you go through that link, you will get some Google Drive. You can download the presentation. It will be in PDF format. Just go to the Google Drive. I will not do this here. It will be shared by NPTEL team. You will get some mail or message on NPTEL website. Just go through it and check. Yes, thank you everyone for this warm gratification. Thank you everyone. Yeah, thank you Amal, Sandeep, and I missed some name Ganesh, Saravana, Sakshi, Sarala. Thank you, Bhavani, everyone. Please join the next session on time.